Hello everyone. In this video we are going to perform the MATLAB simulation of the boost converter in open loop mode. So we are going to perform the open loop operation of the boost converter. So for this we consider the input voltage as 200 volt and the output voltage as 500 volt, and the duty for the boost converter is calculated with this formula. It is 1 minus V in over V out. So if we run the simulation, if we run this code, evaluate this code, we'll get the duty as we'll just find out the duty. So we got the duty is 0.6, so in percentage it will be 60%. Okay, and the other parameters which we have considered for the boost converter, that is switching frequency is 1 kilohertz, and the inductor and the filter inductor and capacitor are calculated from this book, Mohammad H. Rashid, Power Electronic Circuit Device and Applications. So you can find the formulas to calculate the inductor and capacitance for the boost converter for given specifications, that is input voltage and output voltage and the switching frequency. Okay, so now we just move to the simulation. So what thing we require for the perform the boost converter, that is one is DC voltage source, IGBT diode, series RLC, branch, voltage measurement, scope, number of input we just connecting as 2. Now we just set this is input voltage. Okay, we just make all the connections of the boost converter. This is inductor, this is capacitor, and this is load. Okay, see, this is load resistance R, and this is inductor, and this is V out. We are just measuring the output voltage, and we are just measuring the input voltage. Okay, now we don't need go to block. This is V input, and the tag visibility we just make the global. Here this is V out, and the tag visibility we just make it global. Now we are just connecting the blocks, input block with the scope. Then our input voltage is 200 volt, and the inductor is 96 millihenry, and the capacitor is 240 microfarad. So this is 26 millihenry, and this is 240 microfarad, and the load is 50 ohm. Okay, now what we need the power GUI block for the power electronics applications. Okay, and we just make the time as 1 second. We just run the simulation. Okay, now we need the pulse generator, as it is open loop, so we have to create the PWM pulses to trigger the IGBT, to turn on and turn off the IGBT. So how can we give the pulse with the help of pulse generator? This block consists of the amplitude, the period, and pulse width, and the phase delay. Okay, so the amplitude of the pulse will be 1 and 0, and the period will be it is in seconds. So the switching frequency is given as 1 kilohertz. So uh, 1 by f, it will give the period, so 1 by 1000, and the pulse width is zero point 0.6, so it required the percentage of the period, so it is 60 percentage of the period, and the phase delay we just given as 0. Okay, so this will create a PWM pulse of the 60% duty ratio of the 1 kilohertz switching frequency. Now we just run the simulation. Let me see. Now you can see this is the input voltage. The yellow one is the input voltage, and the blue one is the output voltage. Input voltage is 200 volt and output voltage is 500 volt. Now if you want to add the legends, how can we add the legends in the given figure? We just go to setting, this icon, and here you can see here just click on this part, show legends. Okay, and you can check, you can give the different layouts, like it will be in two different this waveform will be visible in two different scopes, or here the waveform is in a single scope, so you can change the scope also from here, and the legends you can set from here. Okay, so we just apply and make it okay. So you can see here the blue is Vout1 and the Vout, and the yellow is Vout1. So we are getting the V in is Vout1, it is coming from Vout1, and the Vout is coming from Vout. Okay, so once again we will go. So this is your input voltage, this is your output voltage. Now we will see if we are changing the switching frequency, what will happen in the output voltage. Okay, so now instead of 1 kilohertz, we just make the switching frequency of 10 kilohertz, and we just analyze the waveform. This is input voltage, this is the output voltage, and we just run the simulations, and we just analyze what will happen to the output voltage while we are changing the switching frequency of the converter. Now you can see the output voltage becomes somewhat smoothing, and the oscillations in the output voltage become somewhat more smooth while increasing the switching frequency. So we can conclude, if we are increasing the switching frequency of the converter, we can get the more smooth output voltage in terms of oscillations, and we will get the output voltage with reduced ripples. Okay, so this is the operation of the boost converter, and which will increase the input voltage to the desired level based on your duty. Okay, if you have any queries on the boost converter, you can ask me on the comment section, and if you haven't subscribed my channel yet, go and subscribe the channel, and don't forget to like and share these videos. Thank you very